One of BASF's first ammonia reactors stands today in Ludwigshafen as an eloquent testimony to the industrial implementation by Carl Bosch in 1913 of the laboratory-scale ammonia synthesis developed by Fritz Haber. The production of this important basic chemical still has its firm place within BASF's chemistry Verbund. To combine the two starting materials, nitrogen and hydrogen, to produce ammonia, the bonds in the diatomic nitrogen molecule have to be broken. Under high pressures of more than 150 bar and temperatures above 400 degrees centigrade, nitrogen adsorbs onto an iron-based catalyst and is split up into atoms. Hydrogen can now be adsorbed and ammonia is produced. The catalyst itself remains unchanged. This reaction generates heat, and therefore the reacting hot gas in the ammonia reactor is cooled with a supply of cold gas. This is achieved with a sophisticated flow system of synthesis gas based on the heat exchange principle. In this way, the so-called equilibrium reaction can be prevented, in which the ammonia tends to decompose again to its constituent elements. The ammonia is collected as a liquid and stored in tanks. The remaining synthesis gas is returned to the reactor and forms more ammonia. An important precondition for ammonia synthesis is the efficient production of pure hydrogen. In several process steps, this precedes the actual ammonia synthesis. In the primary reformer, first the natural gas methane is heated together with steam to about 800 degrees centigrade and is thereby converted into a mixture of carbon monoxide, carbon dioxide, and hydrogen. In the downstream secondary reformer, air is then added and the remaining methane gas is converted at above 1000 degrees centigrade by means of catalysts, and nitrogen is added. Since especially carbon monoxide but also carbon dioxide would damage the iron catalyst used in the ammonia synthesis, they have to be separated off. Carbon monoxide is converted into carbon dioxide in a two-stage process using special catalysts. The carbon dioxide can be removed by a chemical scrubbing process. What remains is the pure synthesis gas consisting of 3 parts of hydrogen and 1 part of nitrogen, which can now be transferred to the actual ammonia reactor. A good 3/4 of the global output of ammonia goes into fertilizer production, while the remainder is used for technical products. BASF, the chemical company.